Hello, hello. Where did TIS go? There we go. Okay, it's back. All right. So I think we left off. We've got these last few to go. Yeah, we wrote a program for that one. Did we? No, we did not. Oh, we did. We did. Return to the segment list. We did one for this one that was pretty bad. And then we're moving on. Next up on the list is going to be the signal divider. We're going to wrap up these last four. Yeah. Last four. All right. Signal divider. I guess I should start. Hope everybody's having a good day. It's a good day post-holiday. So, welcome back. Or not. Anyways, yeah, let's get back into it. All right, signal divider. We're going to read values from n.a and n.b. We're going to divide n.a by n.b, and we're going to write the quotient to q, and we're going to write the remainder to r. Oh man, division. Division is fun. I don't know that I've ever hand implemented division before. That's interesting. It's going to basically come out to, I want to say, what do I want to say? I want to say it's going to come out to just repeated subtraction. So we're dividing A by B, so 47 divided by 3. What is that, 46? What is 46? Is that 13? 13 is 30. That's not 46. 8, 9, 10, 11. 45. It's 9. 45 would be 15. So, yeah, 15. 15 plus 3, right? Yeah, okay, 15 and 3. I mean, I was looking at them right here. I was trying to do it in my head. Not very good at math in my head. So that's 15 threes to make up 47. I don't know if we're going to use these stack memory nodes. They look conveniently placed, so they probably are beneficial. But I'm not sure exactly what we would put there. Yeah, we need to read in the values, obviously, so move that in the accumulator because we're probably going to write it into multiple places. I'm thinking we're actually going to do the division twice. We're going to do the division on this node, and we're going to do the division on this node. This node's going to be responsible for getting us the quotient, and then this node will be responsible for getting us the remainder since they line up there. So we'll just move up straight down, and we'll move up straight down. And so we'll do move up, down, and then we'll move, that's to the right, down. All right, GHT, that'll get these values. And then we can move the accumulator to the right. And so this will move the accumulator left, move left, down, move up, down, accumulator down. And this move up, down is accumulator down. Okay, so that should be getting both of those values in. So we'll just move up into accumulator, save it, and then we'll do the same thing here just to make sure that we've started off correctly. We got 47 in and 3 and 47 and 3 over here. Okay, so that gives us our starting points. We need to repeatedly subtract the numbers. So I'm thinking we may use the stack node to just push values on and off. We've got a count that we'll need to increment. And we'll have a current value, and then of course we have 3 numbers we need to keep track of. We need to keep track of the current value, which is going to be 47 minus 3. We need to keep track of the divisor, which is going to be 3. That's a fixed one. And we need to keep track of how many divisions we've done up to this point. That's kind of a tough one, because if I push a value onto the stack, I can't save memory by reading it off. I wonder if I should just try looping this in a way, like have these 4 nodes actually do the process. Instead of trying to shove everything into this node, I'm wondering if I just push the values on here in a specific order, pull them off, do some math, push them this way, they'll get pushed back up and back on here. And once I hit our 0 value, we'll move this here, and then this will signal for this to pull back in values. I'm going to work on that assumption. We'll start there. So the first thing we're going to do is we're going to move our current quotient onto the stack, which is left. Then we're going to move up left, and we're going to move up left. So we're writing 3 values here. If we step through there, we've got our 0, we put 47 and 3. Do we want to do 47 and 3? Interesting. So I'm thinking, I think I might want to do that in the reverse. So we'll move right down first, and then that gives us 3 and 47. I don't know why I deleted that. Okay, yeah, so we got 3 and 47, so we'll pull 47 off here. We'll pull 47 off, so we'll move up into the accumulator. And then we'll save it. We'll move up into the accumulator, and then we'll move the accumulator up. We'll swap. Move the accumulator up. We'll swap at that point, and then we'll sub up. Then we need to do our test on the accumulator. So if we're less than the current number, so we need to move it up again. So sub up, jump less than 0, done. And if it's not, we need to add up. I think I'll just save it. Then we can swap back to that value, and we can move it right. Move. Oh, I don't think I have enough. Move up, right. Yeah, we need to push it in 3 times, that divisor. So we're going to move that in the accumulator, and we'll move accumulator left. I think I did the wrong one. I did do the wrong one. We want to have you all happen here. Yes. because we'll pull that first value off. Okay. So now we move up into the accumulator. We sub up. That gives us the new value. We save it. We sub up. And then we jump less than 0, done. If we're not done, then we're going to add up. We'll just swap. We'll swap. And then we can move 1 right. That's going to be our signal that we're not done. Then we're going to move accumulator right. We're going to move up right. We're going to move up into the accumulator. We're going to add 1, and we're going to move the accumulator right. And then if we are done, we're going to move 0 right. Really all that we're doing is we're changing what we move right. All right, so done, I'll move 0 right. Then we move all of the same things to the right. So we just need to jump, continue. Do I have enough room to type out? Yeah, jump out. So that'll move 1 or 0 right. And then we should be good. We should be good with this node. So let's test that. So we push our values in. Okay. We move 0 in, and it immediately gets read out. That's not ideal. Yeah, this is why I don't like having stack nodes, because the stack node is always outputting, and always outputting creates a problem. That problem is that we just don't know. Sorry, I was distracted there for a sec. The problem is we can't control when we read, because basically we want this to start reading once we write the data into it. So I'm wondering, yeah, great. I'm wondering if we should do something else. So, son of a gun. What do we want to do? I guess we can change the order that we write into it. The first number, so the first one it assumes is going to be this number. And perhaps we do, instead of down, since down's going to be, we're just going to blow up our node count. I just realized we're actually one less node over here, which means whatever we implement here, we've got to be implemented here, so we should be using these 3 nodes. Shoot. That's fine, actually. That's fine. So we write here in a predictable order. So we move up into the accumulator, which gives us the initial value. And then that's the one we want to move up to the right. We want to move that one on. Then we want to move the right, left, move into the accumulator, and then we're going to move right, left, move right, left. I think we only use it twice, and then we'll move 0 left. Now that's our init, and then we're going to loop here. until we're done. So loop is going to be moving down into the accumulator. Jump is 0, back to init. Otherwise, we're going to jump back to loop, and we will move those values on. So we'll move down right, move down accumulator, move down left, move down left, just like that. It's basically duplicating that last one, and then we'll move. This one is the accumulator, and then we'll move that last value. So this is just kind of cycling. We're gonna cycle between moving the values in and then moving the values around. So over here, we are going to move left into the accumulator, which is our big number. It's gonna be 47 to start with, and then we're gonna subtract left, which is gonna be the 3. We're gonna save that, and we're gonna subtract it again. So that's our second 3. And then jump less than 0. Jump less than 0, we swap. Before we swap, we need to move, I don't think we're moving 3 out, because we had 3 3s. So I don't think we're moving 3 on. So we do need to write it. I do have 2 more. So if I move accumulator left, I did it again. Accumulator. And then here we need one more. Move accumulator left. Okay, so we're swapping. We are moving 1 down. Let's do that last, I think. So before we swap, we'll move 1 into accumulator, and then we swap. Hang on. This is the continuation. So we have the current values and back. So we're going to move 1 into accumulator. And then we jump to output. If we're done, we move 0 into the accumulator. Then output starts. In output, we want to move the values in a specific order. So we're going to move our total, so we have to swap. And then we move accumulator down. Then we move accumulator down. Actually, I just had an epiphany here. We don't need to keep track of this value in... Yeah, we don't need to keep track of our running total. We'll keep track of that one on this node here. So this node will start by moving 0 into the accumulator. And then we'll save it down. Okay, so now that we only have that, we've written 0 and 1. We move the accumulator down. And then we swap. Do we need to swap? No. Yes. Then we swap. But before that, we move, what is that, right down. Okay, that's going to be our divisor. Dividend, I don't remember. I don't remember the proper names. I'm not a math teacher. If we're correct, that should push. That didn't do anything. Why did that do anything? You're going right. Move up right. Move up into the accumulator. I just realized I'm not sending that value over there. So yeah, move up into the accumulator, then move up right. That's right. And move up left. That's left. And then move right into the accumulator. So this is gonna move up into the accumulator, move up. I need to read it first. So, but I need the same pattern over there. Shoot. They need to write to each other. That's not working. What do we do here? What are we gonna do? Well, we can reverse the order, I think, to offload the idle node. I don't really want to involve other nodes, but maybe, yeah, I can't really because I don't have this node, so I don't want to use this node. I want to try and do it without. But I need both values in both of these nodes, which is a lot of operations. Most of the operations are spent duplicating that dadgum left value, that 3, because I can't save it. I mean, I could save it, right? So, but then I still have to write it multiple times. It's just tough. It's tough. I'm gonna get one side working, and then we'll see where we can improve it. Because right now I don't have anything working. So we're just gonna move up to the left, and then over here we don't need to move up into the accumulator right now. We're just gonna move it left, and then we move left. No, we move right to the left. Right. Move right into the accumulator. We move up left. We move right into the accumulator. And then we move the accumulator left, left, left. Yes. All right, so that gets us 47, which is never read because I'm reading from the left, and I mean to read from the right. 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 Goodness gracious. Okay, we've got 47 in, we've got 3, we subtract it, we save it, we subtract again, we're not done. We move 1 into the accumulator, we go to output, we swap, we move 44 down, then we move the right value down, then we swap and we move our output down. So the output's going to be the first thing that we read off. Oh no, it's not going to be the first thing we read off. I actually need the output for this node. I need it in the opposite order. So we move the accumulator down. So why even move it? Just move it down. Don't even move it. I don't even need it in the accumulator. Move it down. So that's already been moved down. Then we move the accumulator down. We still need to swap before we move the accumulator down. Yeah. Then we move the accumulator down. Okay, so then the value should get pushed in 144.3. That's backwards. Hang on. Because you need to be last. Why am I writing the accumulator down twice? That's a good question. Okay, why did I do it that way? Because the first value I read off, because this one's going to read immediately. And so it's going to read the 1, which is going to tell us what to do. So we're going to move 0 into the accumulator, save it. That's going to be our init. Then we've got our loop, which is going to be move left into the accumulator. If it's 0, we're done. If it's not 0, we swap, add 1, save it. And then we've got to move them on. So we move left, up, move, left, up. And then when we're done, we move left, nil, move left, nil. And then we just jump to done. We move, I'm going to say we just move the accumulator down here, and then we go back to initialize. If we aren't done, we jump L at that point. So that should read off 1. So it swaps, it adds 1. We save that. We move left up. We move left up. And then this cycle starts back over. And then up here, we have our loop now, where we have a different order of things. We're moving down. That's the number. We're going to move that immediately there. We're going to move down to the accumulator, move down left. Nope. Nope. Move accumulator left, move accumulator left, move accumulator left. And then we jump back to the loop. But that needs a terminator as well. We need to switch back to that. So move down into the accumulator, jump if 0 to init. That's good. Because then we can move the accumulator left and then move down into the accumulator again. Oh, buddy. Okay, yeah. So we have to go through that extra process. So then if we're done, we move left nil and we move 0 up. Should we move? I think we should move -1 up. And then this one should be jump less than 0. And so that should cycle in. We get 1, we got 44. We got 141. 138.3. 135. And so if we run that, we got a 0 out. What happened? Let's get to done here. Don't have any more room on this line for, come on. There we go. Okay. Let's try running that again. I want to get to a point where we're done. All right. So we're done. We need to swap. we do need to swap before we move that accumulator down. Swap. Yep. We're running. We're off by 1. We're off by 1. We are off by 1 because... Why are we off by 1? I mean, some of the answers are going to be 0, right? Oh, I just had a realization. We will have the remainder. We don't need to duplicate this. We will have the remainder. We'll worry about that in a sec. We're worried about the quotient right now. None of these values come out to 0. So I think we can just assume that we're going to have an off by 1 and just cheat it. So that should just give us the answer. Yeah, so that gives us the remainder here. Okay, so once we get to this point right here, I can't, okay. Once we get to this point, okay. We don't have anything on the left yet. We've got a 2 that's going to come in, so we've got 2 there. And this 2 is the remainder. Yeah, see, that's the remainder. So we actually just need to push that down. Like, move that down. Move that down. And then we'll eat the last value, the next value in there, so it doesn't build up. And yeah, so then the first value is going to be move up to the right. And then over here, we will move left down. And so we should be done. Did we do it? We did it. Boy, it is slow. Oh my gosh, it is very bad. Wow. Very, very bad. 15,000 cycles. That's a lot of cycles. We're not even, average is down here around 6,000 cycles. So, interestingly, how do we do this? How could we optimize this? Because we got a lot going on here. So how could we optimize this? I don't know that I have a good answer for optimizing it. Other than maybe involving more nodes. Where... There's got to be a trick somewhere. We don't have any multiplication. We don't have any division. We could maybe just add up the number and count that way until it's less than 0. So that's an option. So I want to escape back to the segment list, and let's copy this and let's try that out. So what we're going to do is instead of iteratively subtracting, we're going to add up the one number and keep count of it until it is greater than the initial value. So we're going to move up to the left. So that's going to be our main number. Actually, we're going to move up, down, because we're going to keep track of that number elsewhere. And then over here, we're going to move up to the left. So that's still, that didn't change. Then we're going to move right, left. That one's going to go to the left over here. And this will do that work. Then we're going to start our loop. And of course, we'll jump back to the loop. So we'll move down into the accumulator. If it's less than 0, we go to init. If it's not less than 0, then we simply need to do some work. We're going to move, it's the same pattern. We're going to keep the cycle, but we're going to move down is going to go left, and down is going to go left. So it's just going to be those two values, which isn't going to work. It's not going to work because we need the current sum, which is going to be 0. So move 0 to the left. Then, oh, we can do that second. We can move up, down. Move 0 to the left. Then that needs to go into the accumulator. And then we're going to move the accumulator left, move the accumulator left. Because we still need the original value, so we have to duplicate it. Over here, we're going to move the sum from the right side. We're going to move the sum into the accumulator. We're going to add right. And then we're going to move the sum down. And then we're going to move right down. Oh, well, we need to keep track of one more number. So move right into the accumulator, save it, move right into the accumulator. Okay, so we've got our sum and our working total. Wait, the sum is that number. So I think we can still keep track of our quotient down here. That's fine. We don't need these like doubles. So that's going to push the big number down. So we're going to move up. Move up, left. No, move up into the accumulator. We're going to save that down, and then we're going to move 0 into the accumulator. Move 0 into the accumulator. And then move up into the accumulator. So that's our big number. We're going to move the accumulator down twice because we're going to need it twice. Do we need it twice or do we need it 3 times? Oh my gosh. We need it 3 times. Goodness gracious. Move the accumulator down. Man. I mean, we can duplicate it there. It's fine. Okay, so we've got our initial number, 47. So what we're going to do is we're going to loop here. We're going to sub. Wait. It's pushing the sum first. Yeah, I need this to not duplicate there, because that's just gonna be move right. That's left. That's left. Move left, right, and then over here we're gonna move right, left. No, we're gonna move left, left, move left, move left into the accumulator, and then move left, move the accumulator left, move the accumulator left, move the accumulator left. That's going to be our duplication. So we move it over here, it duplicates over here. Then we can just sub right. So we subtract the right side. If that is less than 0, we're done. If it's not less than 0, we need to add right, and we need to move accumulator up, which is our initial number, or our sum, and then we need to move the left up, which is going to be the value that we're adding. I don't think I need to keep track of that one, actually. Okay. Yeah, because that'll save operations, really. And we're gonna have it in the accumulator here. Move 0 left. That's the sum. Move right into the accumulator. Move the accumulator left. Move the accumulator left, because it needs it twice. And then this is going to move down to the left, which is going to be the sum. Then I guess we should save. Move down in the accumulator, jump less than 0 to init. If it's not initted, we need to move the accumulator left, swap, move the accumulator left, move accumulator left. Okay, so we're going to keep the 3 in this node, and we'll just pass it on when we need to. That should work, and then this is going to move the sum here. It's going to add more to the sum, and then it's going to move the sum down. And that's it. That's all it needs to move down. Move the sum down. Which is going to be a problem because it does a lot less work. Well, no, because that's going to be blocked waiting on this, so it is going to be a cycle. Okay. And we need the sum twice at least. So let's just move it down twice. That's all that node is going to be doing now. We don't need to be... Oh, I see where the 3 comes from. Yeah, we're going to write it down 3 times because we're going to use it. So this is our quotient. We save it down. Then we store the original value. And then we move left, right, which we don't need that anymore. We don't need to initialize that. We just need to subtract right. If it's less than 0, we're done. If not, we need to add right to get the values back. And then we need to move right up. My dog is whining. Oh, she's dreaming. Okay. Move right up. What's next? I've lost my train of thought. Okay, so we've subtracted from our global, so 47. So 47 minus 3 will be our first pass. That's not less than 0, so we want to add 3 back to it to get back to 47. And then we're going to move that value up so it gets processing. Then we're going to swap, add 1, and then we've got to swap again and jump back to loop. Boy, I hope done is good. We're going to move -1 up. And we're going to swap and move accumulator down. But this time we don't have the quotient. So we're going to move the accumulator down, swap, move accumulator down. That does not give us what we want. We want to read value. Let's just see where we're at. Okay, so we're gonna go through. We've got 3. We write our 3s in there, and then we're deadlocked because we're subbing from the right when we need to be subbing from the left. Left. Okay, we got that now. We've got 47, we subtract 44, we add left, we move left up. What happened there? We move, yep. And then we move left up. Moves down into the accumulator. Moves 3 left, swaps, and moves it left twice. Why does it move it left twice? It doesn't need to move it left twice anymore. Okay. So that moves 0 and then 3. Then we wait for 3 to come up. We move 3 over. And then we move 3 over. And then it writes 6 in there several times. And then we write -16 down, which is not what we want. Why is it -16? Okay, I only care when we're done. When we get to done, let's get to done. Okay, we're at done. We have -16 and 6, so something is going wrong. Let's try and figure out where we're at. Okay, so we trace through. We've got 3 coming in, and then 3 turns into 6. 6 turns into 9. 9 turns into 15, which should be 5. Why are we not at 5? Give me a moment. And we are back. Okay, where were we? We were failing to implement division. Who would have thought division was this hard? Where are we at? Okay, we have to start over again. Okay, so 3 comes in. 3 should be our 1. We do add 1. 6 should be our 2. 9 should be our 3. Why are we... Oh, because we're off by 1, right? So we're at 4. We're at 5. What? Where did... Sorry, I missed it. Okay. 3 becomes 6. Becomes 9. becomes 15. 15 gets sent up. 15 is moved over into the sum. We swap. We move 9. Why did we move 9? Oh my goodness. I think I see what's going on. We're losing our value here. Okay, so we move. And then we move the accumulator left. So we write 6 there. We swap and send 3. And then we need to swap again. We need to swap back or just save it. Doesn't matter. Okay, so that should be... There we go. We're getting our numbers adding up. Okay, we've got 15 and we've got -1. And we've got 48 coming in. So none of that is helpful because that's not going to give us our quotient. Yeah, that's not going to give us our quotient. Which means we need that 3. We need that 3 down here. We need that 3 down here. So we're going to move up into the accumulator, move up to the left, and move up down. Yeah, I didn't really want to involve these nodes, but this is where we are. Into the accumulator. That is up. Then we're going to add left, and we're going to move the accumulator down. So -1 plus 3 will give us 2. And then that'll be our remainder. Okay, back to running where we're at. Okay, so we're here. We move 1 up. We move the accumulator down. We can't move the accumulator down because we have a dummy value there. So we need a done. We need a done. Done is going to move down to nil. So that should block us there. Actually, jump less than 0 to done, right? So I don't even need that. I can just move the accumulator up. I still need to swap though. Give me a moment again. All right, we're back. The joy of being a parent. It's always fun stuff. Okay, so I think we're at an impasse. We've got to this point. Let's get back there. So we get to this point where we have what we need. We've got the -1 that we want, but we need to move that up. And then we need to move that down, which isn't going to go anywhere. Then we swap and we move the 7 down. What? What are we doing? Why has B read so many values? Okay, yeah, I need to get the accumulator. Oh my word. There we go. I don't know why reading more than that. I don't know. Okay, anyways. We now can move that up. But you can see we have this problem where we need to read these two values out. I just did it again. Okay, so we need to move up to the right and then move up down. We're just waiting on it to hit. There we go. Okay, so we're going to step in. We write our -1 up. We write our -1 down. That gives us 2. That gives us 2 out. That gives us 15 out. So we got the correct numbers there. But but we have 2 lingering 48s here, which is not good. We no longer have that to read. So how can we get rid of those final values? Once we write both of those up, we write those down. Maybe after that one, we move 1 to the left. And then over here, we can move right nil, move up nil, move up nil. And then it just kind of waits. So maybe that can be where we clean up. I don't like it. And I think it's going to be a race condition. But I also don't know of a better way to do it. Can't think of a better way to do it. We move the accumulator down or up and then down. And then we swap and we move that value down. It cleaned up quite nicely, actually. Okay, maybe that will work. Let's remove our debug statement and hit fast. And see where that gets us. That is chugging along, still pretty slow, but better. We're nowhere near the group. Okay, I really want to learn this one. I think we're going to go back to the segment list this time, and let's do some learning. So let's see, TIS-100. What is this segment called? Signal divider. Let's see what kind of solutions we get here. Wow, this is a pretty simple solution. This is a very simple solution. What does it do? Open image and new tab. Well, that's complicated. Wait a sec. Double division and 2 division at the same time after the first one. Okay, there's a lot more node usage, but it's doing a lot faster. So let me, I know you can't see the browser, so let's get this over here. So this node moves right in the accumulator, moves the accumulator down, moves the accumulator down. This node moves up right. We have a main node here, move up right. We have a move up down, move right accumulator, move accumulator left, add accumulator, move accumulator down, JRO down. Interesting. I wanted to use JRO, but I haven't found a good reason to do it. JMP main. Okay, over here, we move left down, move up accumulator, move accumulator right, add accumulator, move accumulator down, jump loop main, move left down. Okay, now it's gonna have to down. Move up accumulator, move up left, move accumulator right, add accumulator, move accumulator down, loop, JRO down. So JRO is one we haven't really looked at yet, and it will jump relative to the value in this buffer, so wherever this is reading from. So in this case, it's going to read a number from down that will tell it to jump how many lines relative. So jump 1 would jump here, jump -1 would jump here, and so it'll be jumping around kind of uncontrollably. Move that. Okay, so that's the first row. This one, we've got another set of big nodes here. We loop sub up, jump less than 0 done. Move -1 up, move -1 down, jump loop done. We're adding left, move 1 up, jump less than 0, adjust, move 2 down, move left nil, JRO3. Interesting. That's just straight up, instead of using, I guess, more labels, that jump feels, because it's hard coded to 3, feels kind of pointless. We'll take a look in a moment. Just add left, move accumulator down. What happened? I put a space there. Okay, good job. Move up accumulator, loop sub up, jump less than 0 done, move -1 up, move -1 down, jump loop done, add right, not down, done. Thank you. Move 1 up, jump less than 0, adjust, move 2 down, move right nil, JRO3 again, adjust, move 1 down, add right, move accumulator down. Okay. 2 more nodes to go. Let's see, move right down, main, add 2, JRO up, sub 1, sub 1. Okay. Move right down, move accumulator down, move up right, move 0 accumulator, JMP main. I think some of this is just there to obfuscate, honestly, but we'll take a look at what's going on. Sub 1, move accumulator left, move up down, main, move 0 accumulator, add 2, JRO up, sub 1, move accumulator left, move up down, move left down, jump main. Okay, so if we just run it, it is extremely fast, and it solves it. It uses a lot of nodes, more nodes than we did, and it uses a lot more instructions than we did. But look at that cycle count. Unfortunately, it has tainted my score. But let's take a look at what's going on here. So this is going to move right into the accumulator and move it down. So these nodes are basically just reflecting these values into the stack. When do they get written? Why is that one stuck on move up to the right? Oh, we're moving that this way. And so that's dividing numbers, JRO up, so -1, add 2. I think it may have just unrolled in a fancy way. So I want to look at this JRO3 here, right? Ooh, why are we in insert mode? I don't want to be in insert mode. JRO3, right? So if we just run it until we get there. Okay. One moment, and we're back. Should be maybe the last interruption, but probably not. Okay, back to JRO. So JRO 0 is going to jump. Get my window back up here, just in case someone decides to talk. I will be there to respond, hopefully. Okay, so JRO, again, jumps relative, so 3 should be 1, 2, 3, so it should move accumulator down. So if we hit step, you can see it's jumped here. Now, if we'd simply done something like, I don't know, jump end, except jump is not the word, and then we put in an end, we get the exact same flow, except it's a little more clear. Like, see, it jumps down to end. And then, of course, if anything is added in between end, that's great. So, like, JRO is really useful if you have a way to manipulate your jump directions, but if you don't, it's better to use the iterator. So again, I think we've unrolled the loops here. So if we're watching these values flow in, we got 47 coming here, and then we bring in 3 comes in there, 3 comes in there, and we, oh, I missed it. We move the up into the accumulator, which is our 47, then we subtract up, which is 6. And then we move -1 up, and we move -1 up, -1 down, which gives us, we're basically telling like, hey, you jump back up and redo that, send me a 6. So it's like, send me a 6 again. And it looks like we've got these 2 3s queued up over here. So I imagine we've unrolled, we're doing 2 divisions at a time. So that's the 6, that's where the 6 is coming from. And then, one sec. And then as we go through this process, we'll get to a point where, yeah, so that's -1, jump less than 0 to done. So then we add the right value. That gives us our remainder. And we move 1 up, which jumps 1 down to main. And then that starts over, and then I think we swap and we do the division on the other side. Why is that got 3s there? Is it the same? Was it just taunting us? So it's already queued up 12 to run. So anyways, yeah. That's a very, very creative way to do it. I went ahead and erased that because it's not really mine. I don't think this is going to restore my terrible cycle count, but it is the best that I accomplished. It's not. That'll be forever tainted. So we won't be doing that again. At least executing. Okay, we've got 3 more to go, and they're only getting more and more complicated. So this one hopefully won't struggle on as much. Sequence indexer. Sequences are 0 terminated. Read a sequence from n.v. So there's only one sequence here. Read index values from n.x. So that's these numbers here. And then look up index value in sequence. Okay. Look up index values in sequence. Isn't that fun? Yeah. Yeah. So these numbers are going to have to be our list, because if we read the sequence in as 860 here, then 215, then 230, then 784. But index 0 is 860, so this first value is index 0. So we need 860 to be the top of the node. So we actually want it to be down here. So what I think we'll do is we'll move up to the left. We'll just move up to the left. We'll move it into the accumulator. If it is 0, then we're done. And when we're done, we move 1 down. Otherwise, we jump to the loop. You know what? Why? Let's obscure it. We're gonna go -2. We're gonna go up here, right? So that's gonna read our values, and we are pushing. Where are we pushing? We're not pushing anywhere. We need to move the accumulator to the right. Yeah. So that's actually gonna have to be -3 now. This is why you don't want to use this when you're hard coding values, because you never know like what's gonna happen there. Okay, so that's our sequence. That's our sequence. I guess we want to put a 0 in. Move 0 into the sequence. So we're gonna move 0 right first, and then we're actually just gonna jump to our start. I'm actually thinking, I mean, either way, it doesn't really matter. We don't want to jump to like loop, and that's our loop. And then here, like, we don't want to go back to moving 0 to the right. That's the thing. We don't want to go back to moving it. So I think we'll move down up, because up will never write back. So that'll halt that node. I don't really like it. The only other solution is to put like a no-op and a jump, and have it just constantly do the no-op. Like, instead of that, we could do like a no-op and a JRO right back up to the no-op. So that'll push all those values in, and then it's just going to sit there idle. Why did it go back to done? Oh, nothing's reading. So if we move up to nil so we can simulate that read, then you'll see that it goes there. And it's not idle at all. I think that's going to count towards our cycle time. So I'd rather be wasteful and just move a value down that's never going to be read, because then if we move, for example, when we move up to the right, so we simulate this never writing again, then that will become idle. Okay, once we have the values here, we need to sequence them, basically. But how do we want to sequence them? We want the number. We want the number that we have of the values. So we've got that. Let's not move 0 right, then we don't have to worry about this hack. Move that into the accumulator. If it's 0, we are done. When we're done, we're going to swap and move the accumulator down. So here we move the accumulator right, we swap, add 1, save. So now that should read in the values, give us a count of how many values, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we had 10 values, and then that's going to write our length. Why didn't it write our length down? Oh, it did write our length down. And then over here, we are going to move up into the accumulator, and then we'll move the accumulator left to the right, and we'll just jump L. Yeah, so that'll just continuously write our length into this middle node. We will read in an index, move up, down. So we have an index now, and we will move up to the left, move up to the right, right. Move up to the right. I said right. I meant left. Move it to the left. Okay, over here, once we've moved it to the left, so that's going to be, read that in. We've got 10 here, and we've got 0 waiting. So we want to know how many numbers we need to read off from the top. We need to read 10 numbers. So we move left into the accumulator. We sub right. That tells us how many we need to read. Then we do our move loop here. We're going to move up, down, sub 1. Jump equals 0, read. Maybe like move 0 down, so we have a 0 down there. So we move 10 values down, then we move up into the accumulator, down into the accumulator, and we move the accumulator up, we move accumulator right. So we move left down, and then we jump, this is jump back to move L, and then this is read, and this is reset. Reset needs to move up accumulator, jump equals 0. Let's just JRO it. No, we need to jump equals 0 to init, or to start. Okay, we got start. We're gonna jump if 0 start. If we're not restarting, we're gonna jump back to reset, which gives us a total of 2 commands, which is we're just gonna move down, up, move accumulator up. I think we're okay. So if we try stepping through, we read all of our values in. Read all of our values in. Okay, we need to read 10, so we read 2, 3, 4, 7, 8, 9. Then we move the top off. That's what we wanted. And then we put all of the values back in the order that we read them from. Wait, sub right. Oh, move up, down. Goodness gracious. So I want to get here. Okay. I guess let's put a no op there so I can, yeah, because it's gonna halt on that immediately. So we read everything in. We're here. Where's 8? Oh, we already wrote 860 out. We've got 5. We're doing the reset. doing the reset. Let's go through the reset. We get back to start. We push a 0 down. 10 minus 5. We read 1, 2, 3, 4, 5. That's the number we want. We write the other 2 up. And that's the number we want. Okay, so we're done. Oh, let's remove this debug. And let's run that. Yeah. Yeah, I mean, compared to the performance in the last run, I'm happy with that. We're actually on the lower end. I mean, not the low end, but the lower of the mid pack on instruction count down here. That's good, 30. We are kind of mid operation, like cycle time, but you know, we're out of this group here. I'm happy with that. That's a pretty good run. We got another person selling views. All right. You are out of here. We're going to ban you. Yep. Sorry. Don't care about buying views. Let's see. Return to the segment list. And boy, I hope this one is simple. But sorting is never simple. Sequences are 0 terminated. Read a sequence from in and sort the sequence and then write the sequence to out. Oh boy, sorting is fun. Basically, we just need to know, like, we just need to find the smallest number. Oh boy. Oh boy. Man, this is rough. So it wants us to write it out and smallest to greatest. So if we write greatest into the stack every round, then we can pull the greatest off. We'll pull the smallest 2 off. Oh man, sorting is a pain. Sorting is a pain. Write the sequence to out. Yeah, okay. So we want to read the values in. So let's just do that. We're gonna move up, move 0, right, move up, right, move up into the accumulator. Jump is equal to 0. We're done. Done is just gonna move 1 down because that's gonna halt us. And then we're going to move the accumulator right, and we're going to jump to read. Okay, so we read the numbers in, and we basically want the smallest number at the front, which we already have. But how do we know that's the smallest in the whole set? We are reading the numbers in, so we could write them such that we have the largest number in memory and the smallest number in the node. Then we can compare to the current incoming number, and if the new number is greater. So let me try and notate this so that I'm not just talking out of my head. All right, so the first number we read in is 67, right? That's our smallest number, so we write it. We just write it down. All right, I'm going to do, there's no so I'll just do D. Right, or we'll move it. We'll move it all the way down here. Then we get 15 is our second number. And we want to know, or I guess I should say, the first number we'll hold in memory. And then we get 15. And we want to know which one is smaller. And whichever one is smaller, which will be the 15, then we write the larger number down. So that'll be 67. Then the next number will come in. I guess we should write the smaller number. See, this is going to be a problem because we have a stack. and we need to reorder them. I'm trying to think of a bubble sort. Bubble sort's probably going to be the easiest to implement with a stack. Although, yeah, because we don't have any division or swizzling. So there's not going to be any like fancy radix sorting or anything like that. So basically, we'll need a comparison. So we can use a node to like do our greater than operation. But anyways, if we read in these two numbers and we compare them, we need to put them somewhere in an order. So if we put the smallest number in here, for example, we try that. Then we get to this point. Oh, we have 67 still. We read in 27 is the next value to come in. So 27 comes in, and it's smaller than 67, so we write 27. And then 87 comes in, 86 comes in, and it's smaller, so we write 86. No, sorry. So we write 67. And now we have 86 here. And then we read in, this is where we read in 15. We haven't even read in 15? Okay, let me start over. We read in 67. Then we read in 27. 27 is smaller, so we write 27 down. And then we read in 86. 67 is smaller than 86, so we write it down. Then we read in 15. 15 is smaller, so we write 15 down. And then we write 86 down. So we've guaranteed that the top of the stack is the largest number. So we could move it over here. Basically just get rid of it and start over. But where do we start over from? That's the fun of the question. Yeah. So then we start over, and this is our new order that they're coming out of the stack. So we'll read in 15. And then we'll read in 67. Of course, 15 is smaller, so we write 15. Well, we can't write 15 in anymore. Just realize that. Yeah. How do we pull all of the values out of that stack and read it again? We need to find the smallest number. We need to guarantee the smallest number. So if we read in 67 and then we read in 27, 27 is the smallest. So we write 67 down. Yeah, and then we'll just selectively pick the smallest number off. But how? How do we do that? How do we do that? I think if this reads here, we can signal to this node, but then it doesn't have anyone to do its job with. Okay. And then we read in 86 is obviously next in the list here. And of course 27 is smaller, so we write 86 down. Then we read in 15, and in this case 15 is smaller, so we write 27 down. And we're left with the smallest value in the list, which will be the first one we write out. So then it becomes a matter of how do we find the smallest value of the remaining items? because we basically have to recycle them so that we look at all of them again, which means we have to read them out, which means we can't write them into the stack, which means, what does that mean? Which means we're going to have a couple of nodes kind of redoing the same thing. Because we have to read all of them out of here into here. The order in the stack doesn't matter anymore because we're just pulling the first item off. I mean, the smallest number off. I wonder if it makes sense, like, if we're reading it in, like, would it be helpful if we read it in? So we read in 67 and then we read in 27. So we have these two values. We're going to write 67 down. Then we read in 86. Yeah, we don't have the context of 67 anymore, so we can't put 86 last. Okay, let's implement this, at least the first part. All right, so we move up nil. That'll get us started. And we've moved everything to the right. Right. We moved everything to the right. So move up left. Move up not left, to the right. Okay. And then I'm going to have this node be our comparator node. Basically, I want to give it two values, and it gives me the greatest one. So we'll say this is going to be greater than, or sort two. Sort two values. Actually, I wonder. It's fine. Move up to the right. Yeah, this will be our sort two over here. Move up right. So this is going to kick this node off. So this is going to move left into nil. And then we're going to read the values greater than. You know what? What am I doing? I stuck with this. The initial push is just going to be move 0, move up, down. Yeah, move up, down. What does that matter? And here we're going to move 0 down. Move 0 down. So we know when to stop. And we're going to move up into the accumulator. No, we're going to move up left. And we're going to move up left. And then it needs to give me the greatest value. So move left down and move left accumulator and the least value. Okay, so we're going to move up into the, or move right into the accumulator, move the accumulator down, and then we're going to move, we're going to save that. Then we're going to move right into the accumulator. And we're going to move the accumulator down. That's going to read back to us. So we've got the first number. We read the second number. We need this number twice. Because once we get this second number in the accumulator, we're going to swap and we're going to sub down. And if that's less than 0, then it was greater. We need to label this. So this is A coming in. So let's just figure it out. Okay. So that means the value coming from below is larger, which means we need to do back. So we need to back, swap, move, accumulator, left, right, move down, right. We want the greater number first, so we actually want that. Otherwise, we want let's do start. GMP start, and we are going to move our accumulator. What are we doing? Yeah, we're moving, in this case, the back value is larger, so we're going to swap, move, accumulator right, move down right. Okay, so that should give us, if we read in 67 and 27, then we should get 67 back first. Why are we... Come on, accumulator. Oh my goodness. All right, so 67, 27 goes in. We get 27, and wait, what did we get? 67, 27 in. We get whoa, what's happening with my numbers here? Okay. We put 67 in the accumulator, we save it. We put 27 in the accumulator, and we send that down. Then we swap. Then we swap and we save because we have that value elsewhere. Then we subtract. Actually, I can avoid that save if I just do one more. Right, up. And then I actually don't think it's going to save anything, because then I'll still have to read it into nil and add it up, so it might actually be worse. So that gives us 40. We send 67 over, then we move 27. So 67 got written, 27 is in our accumulator, And now we're in our main loop. Our main loop is going to be to move accumulator to the left, move up to the left, move left down, move left accumulator. Actually, once we hit a 0, so we move save it. Move up into the accumulator. If it's 0, we're done. I don't think we're really gonna have enough room. There's a lot of work for one set of nodes. I mean, for one node. I mean, I can even, yeah, that's not gonna work either. This is gonna have to be done anyways. Like, I'm always gonna have to do that. So we're gonna do like right, or we'll do store, I guess. So then this can just jump store. What was this save? Move left in the accumulator and then save it. Okay, so that's gonna happen. All right, so move up into the accumulator. If it's 0, we're done. If we're done, then we're gonna move 1 to the right, I guess. I don't know. No, we move the accumulator right. And then right, we'll move left down, which will move up down. That'll be the smallest value. And then we don't start over. What do we do next? Yeah, it doesn't really start over, but the values have to be written into it again. So what I'm thinking is maybe we read this way. And then this pushes in, because then this can read out and push up, which can push back in and continue this cycle. Can continue the cycle. But we need to read all of the values out of here, which at most we can read 1, 2, 3, 4, 5 values before they would get back here. Anyways, let's see if that even works. That does not work. We are getting 15 because we're moving left down. Where are we getting stuck? We wrote 67. Move up into the accumulator. It's not 0. We never did the work. We need to swap. We can move the accumulator to the left. swap, move accumulator left. Right. So that gets 27, 86. We wrote 86. We've got 15 and 27. We wrote 27. We've got 15. We wrote the accumulator, which is not right. We need to swap first. Okay. We got the first value written out. What I'm thinking is these values don't even have to stick around in here. They could get pulled off almost immediately and cycled back in. But I can't read this way and read this way at the same time. So it's like, I don't know. I like the idea of this always being like left. I think this one maybe needs, I don't think it ever needs to read down. That's going to be an incorrect assumption. So if we move all of this right, then this can move up to the left. So this is going to move up right, and then this is going to move up left. So this will go around this way. That changes this node a little bit. So basically, we're moving right to the left. We're moving right to the left.
Sorry, I don't understand.
Good. When we move something down, we need to write a code down, which we don't have the ability to do that. But maybe I'm trying to make this dumb. I'm trying to make this node dumb so that we can kind of just assume that data is going to be flowing through it so I can free up some moves. This is duplicated. We could kind of replace it. Do we need to jump store? We do need to jump store because that we don't. We could move that jump store. We could move this store up here. And then we jump store, so it becomes loop. So this is where our loop starts. And then, do we need this saves? Move left into the accumulator. Move left into the accumulator. We're getting rid of up here. Move it left. If we're done, if we're not done, we're moving that left. Hang on. What did I just replace? Move up. Move right into the accumulator. Because that's going to tell us if we've completed a loop. We have a problem because now we don't have a way to signal back here. We can't both write into this from both directions. Oh, because it's only one. Oh, this is rough. This is rough. Really struggling on this. Man, it's difficult to sort with this route. I mean, our sequences, we can make some assumptions. We got 1, 2, 3, 4, 5, 6, 7. 7 maybe. It doesn't tell us what our input's going to look like. I don't know the best way to do this. Because if this is pushing in and then these two are reading, one of them is going to eat it and the other won't. I guess if I push in the same signal twice, though. I don't know. Let's see. If I want to move left into the accumulator, not left because left is debug, move right into the accumulator, and I want to move up into the accumulator, and I move 1 into, and I move 1 left. I don't want 1. If we step, we put 1 in. We got 1 up there. And we got 2 up there. So like this one is always going to consume it. This one's always going to consume it. But if it did something else like jump equals 0, done, and then let's just put done here, right? If we do that, that reads in 1 and then 2, and it reads in 2. And it reads in 2. Wow. So it would basically, we would have to bake in a NOP, a no-op there, to ensure that this one reads it. That could work. That could work. To the left. That could work because we want to signal to this node to restart. So it's going to move up into the accumulator. Jump of 0, pause. And we'll do that on its own line. Okay, we're going to pause. If we're not pausing, we're going to move accumulator left. Right. We're going to move accumulator right. If we are, and then we're going to, that's going to be read. We're going to jump back to read. If we are pausing, we're going to move Move accumulator to the right. And then we're going to move right into accumulator, no op, jump less than 0, back to pause, and then that'll restart reading if it's not less than 0. If it is less than 0. So if we read that in, oh, then it's going to go straight to reading. It's going to eat the sequence. What is, yeah, it's eating the friggin' sequence. That's what it's doing. Because we want to jump back to pause here. That's what's going on. No. We don't want pause. We don't want that to be in pause. We want that to be pause loop. $27, $86, $15. Okay, so that's pretty much set. Now we just need to get this one sorted. So we are moving right here where we're moving to the right. Where else are we moving? Down. Yeah, we're moving left down. That needs to come at the cost of, like, we need to move a signal down first. So like move -1 down is like continue. And then here we want to move 0 down. So that means stop. We want to move that down first. So we're going to move right, left into the accumulator. If it is less than 0, we continue. If it is 0, we're done. Well, if it's not less than 0, then we can assume that it's right. So we're going to move the left value to the right. That is continue. That is continue. We move left to the right. If we're not continuing, then we're done. Jump less than 0 is continue. If we are equal to 0, we are moving left down. And we're moving -1 right. That moves left to the right. And then that starts back up here. And we're good. Okay, so we're going to move left up. We're going to move down up. And here, we're going to move down to the accumulator. If it's less than 0, we move down, or we move the accumulator left. Move the accumulator left because we need to signal both of those. So jump less than 0, we restart over here. We move up left. I don't think it really matters. Move up into the accumulator. Jump less than 0. Why does it jump less than 0? Jump less than 0, don't write, I guess. We'll jump back up to L. And then we'll just move accumulator. I guess we can just JRO. Right, just go back up. Move accumulator to the left. Oh, that was actually right. Okay. Let's see how we are doing. Oh, right. I remember what I wanted to do because well, I don't I don't have a way to know if I'm done yet. Okay. Well, we'll figure that out. Let's see. We're moving 86. It's okay. Yeah. That was dumb. Jump less than 0. Back to read again. And then that's read. Okay. Yeah, because we're never writing. We're writing that. We're writing that. We're writing that. We're writing that. What have I written out? I haven't written out anything yet. Still haven't written out anything yet. Where was my 0 at? Oh, I do have a 0 length. Nikes. Mm-hmm. 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 Okay, let's set this node up for the way that it's going to behave. We're going to rewrite this node. So before we do anything, the first number we get is going to go into the accumulator because we're always going to have a number in the accumulator that is our smallest number. Now we have our initial loop here. And what we want to do, I guess we want to save that. What we want to do is we want to move right into the accumulator. If it is 0, we've hit the end of the list. We've hit the end of the list and we want to keep going. We want to keep going. Yeah, if it is the end of the list, we want to keep going. So we'll do out. We'll make that output. Okay, so we'll do output to do there. Okay. If it's not output, we want to move accumulator to the left. Swap, move accumulator to the left. Now what we want to end up with is the smallest value in the accumulator before we save it. Which means we get the largest value first. So we're going to move -1 down, continue. And we're going to move left, down, move left into the accumulator, jump, save. When we output, what we want to do is we want to take the smallest value. So we need to swap, move 0 down, and move accumulator down. So 0 tells us to output. Okay, does that work? That gives us 67. We've already moved -1. 67 goes down, goes on. So I think there's a few different signals that we need here. But we'll have to get to it. We move 86. We move 67. Oh, did it eat 15? Yeah, I think it ate 15. I think it ate 15. So I think we just move it into the accumulator. If we read it in, if it's less than 0, we start over. If it's not less than 0, we move the accumulator back into it. I don't like it. I can't think of a better way. Yeah. So that read 0, it puts 0 back. It read 0, it puts 0 back. It read 0, it put. Okay, it's reading 15. That's not working. That's not working. That is not working. What do we need to do? I think we're on the right track. So if we move these values here, let me pull up my stats real quick. We're looking good. What are we at? 8. Yeah. Might have to call it soon. But if we move these values into this stack and we kind of move this logic over here, so it's just reading from the stack, then this is going to read in 67, 27, 86, 0, which is not exactly what I want. But then if that comes down here, so let's try and move that. All right, we're going to move you over here. We're now moving left. The accumulator needs to go down. What was normally left, we're not doing the comparisons anymore. Interesting. Yeah, this one doesn't need to do comparisons anymore. So I think this logic is actually supposed to be here. And then this logic is here. Okay, so we read this way, and then oi, oi, oi. Like, where does the greater values get compared? Goodness gracious. Okay, if I undo that, so if I'm just reading the values in here and over here, I like this kind of right out, and this cycle seems fine. Oh, but then I can't use that one. Son of a gun. Like, there's always one thing. Yeah, I think I'm going to have to pause it. I'm not feeling super well, and I've obviously been struggling on these. These are relatively difficult problems. Like, sorting is usually you need some memory. I'm not going to look up a solution, but I'm going to look up low memory sorts and see if I can find a way to maybe implement something. But anyways, if you tuned in, thanks for tuning in. Thanks for everyone who's followed me. Thanks for anyone who's watching this here or on YouTube. And I'll see you on Thursday. Cheers.